Now that we have graphed quadratic equations and written formulas for quadratic functions, the next thing that is up is solving. At the end of this lesson, you'll be able to solve a quadratic function by graphing. All right, first of all, what on earth does it mean to solve a quadratic equation? Basically, what we're going to be looking at, a quadratic equation is going to be, usually it will end up being a u, it will always end up being a u. What we're going to be looking for when we're looking for solving it, we're looking for where does the graph touch the x-axis. So we're looking for an x equals problem, where does it hit the x-axis. We'd also be, if I'm looking for, if I have an equation x squared minus 6x plus 2 equals 0, we're looking for what values of x would make that equation equal 0. So those are the two ways of looking at it. All right. Another thing, when a problem asks you to find the zeros, it is actually wanting you to find the x-intercepts. So solving a quadratic equation is all about finding where a graph touches the x-axis. In real life, we would be looking for where usually we have something goes up, it goes back down. We're usually interested in when would that object hit the ground. So that would be the purpose of solving a quadratic equation in real life. All right, ways to solve a quadratic equation. We will have 4 of them, what we'll be discussing in this video. We'll just cover one of them. The first one is by graphing. The second one, we can use square roots. The third one, we will do factoring. And the fourth one, we will do the quadratic formula. Okay, all of these methods can be used to solve quadratic equations. Depending on the problem, some will be more appropriate than others. You will need to know all the ways. There'll be some choice involved, so you'll get to pick which one you like the best and do most problems that way, but you will need to show that you can solve using all 4 of those methods. All right, to solve an equation by graphing, we are first of all going to write the equation in standard form. And I'm also going to put over here that we want the problem to equal 0. So if it doesn't equal 0, we're going to have to do a little work in there. We will then graph the related function, and then the solutions are going to be the x-intercepts. Where does the graph touch the x-axis? Intercepts. All right, so let's jump into some problems. On this one, if you were in class, you would have your graphing calculator out and you'd be graphing this, so I will guide you through. I'll be your graphing calculator for you today, but you definitely would want to actually graph it that way. All right, solving by graphing. The first thing that I always will direct you to do is we're going to circle the word solve. The second that I see the word solve, we need to make sure that we say x equals when we're done, because it's going to be very easy to graph these and then forget to actually solve it. So 2 things I need to check for. Is this in standard form? Does it go from the highest power to the lowest? Yes, it does. Does the equation equal 0? Yes, it does. So we are ready to graph it. So I am going to graph this part right here. So in the function screen, that's what I would type in. When I type that in, I am going to get, it's going to touch over here at -9. It's going to touch over here at 4. And this is what my parabola is going to look like, something like that. So when I solve by graphing, we will graph it, and then I need an x equals. Where does the graph hit the x-axis? So these are my 2 answers right here. It hits at x equals -9 and x equals 4. That is your answer. Okay, problem number 2. X squared minus 6x plus 9 equals 0. Once again, we're going to check, is it in standard form? Yes. Does it equal 0? Yes. So we're ready to graph it. And if you were to graph that, again, we're not going to graph the equal 0. We're just going to graph this left side of it. If I were to graph it, I'm going to get something that looks like that. All right, and so when I'm graphing it, I need an x equals. What does x equal? Where does x hit the x-axis? It's right here, and it's at 3. So my answer will be x equals 3. Okay, this next one, if I have x squared minus 25 equals 0, again, it's in standard form. It does say equals 0, so I'm all set with that. And then the next thing I want to do is go ahead and graph it. So again, remember, we're just graphing the left side. We're not graphing the equal 0 part of it. When I do that, this is where it's going to be a parabola that looks something like that. And then it was nice that I graphed it, but I'm not done until I tell what x equals. So what does x equal? X equals 5, and x equals -5, because that's where the graph touches the x-axis. All right, the next one you'll notice, it's not in standard form and it doesn't equal 0, so we need to take care of that. In order to get this to say equal 0, we need to get rid of the negative 8, and we can do that by doing plus 8 to both sides. All right, so if I write this left side in standard form, it would be x squared plus 4x plus 8. I cannot put those together to make them 12x because the 4 has an x and the 8 does not, and then now it will equal 0. So now it passes my 2 checks. I'm ready to graph it. If you were to graph this one, and again we're only graphing that left side, if I were to graph it, I get a graph that looks something like that. So you will notice it does not touch the x-axis. So then since it does not even ever touch the x-axis, we are going to get no solution for this one. All right, I would suggest pausing the video at this point in time, and you can see how you do on this one. First thing, it doesn't say equals 49, so we are going to subtract 49 from both sides before we start. So I'm going to get negative x squared plus 14x minus 49 equals 0. And again, we can't combine those because one has an x and one doesn't. If I were to graph this, I'll get something that looks like that, and I'm not done until I say what x equals. X equals where it touches the x-axis, and that is going to be at 7. All right, I just wanted to do a couple more examples of when it says there might be some different directions. When it says to find the zeros, it really just means to solve, and so again, we will not be done until we say x equals, so it's just looking for where do we touch the x-axis. You'll notice this is in standard form, but it doesn't say equal 0, so we want to figure out where does it equal 0. So that's what we're going to do for that specific problem. And then if I graph this right side, x squared plus 3x minus 10, I will get, touches over at negative 5, and it touches at 2. So that's what the graph will look like. And again, we're using a graphing calculator to get that. You don't have to graph it by hand. Then my answers are going to be x equals where the graph touches the x-axis, and that will be at negative 5, and it will be at x equals 2. All right, and then this last one, again, if I'm looking to find the zeros, we're just looking for where does this graph equal 0. It's already in standard form, so I'm just going to graph the right side. We get to use our graphing calculator to do that. When I do that, I believe it just touches over at negative 2, so it's going to look like that. And so I'm not done till I say what x equals. X is going to equal negative 2 because that's where the graph touches the x-axis. And I guess we get to do one more here. We're going to do this one again. We're going to let this equal 0. And so when we graph this, x squared minus 3x will touch at 0 and 3 actually. Something like that. So if I'm just looking for where does the graph touch the x-axis, it touches at x equals 0, and it touches at x equals 3. So now hopefully you are familiar with solving a quadratic function or an equation by graphing.